Okay, so we're getting ready to start lesson 1.7. Like usual, problem of the day. Make sure you read through the problem. It's a multiple choice problem and select your answer. Make sure you pause the video and then when you're ready to move on to the lesson, to resume it. All right, so in today's lesson, it's part 1 of 2 of lesson 1.7. 1.7, solve absolute value equations and inequalities. An absolute value is the distance number is from 0 on a number line, and we've mentioned this before. So it's distance away. I always use the example of a car. If I drive 1 mile in my car, the odometer is going to register a mile. And like I said, not that I'd recommend it, but if I take my car and I drive a mile in reverse, hopefully not hitting anybody or anything, you're still going to register a mile. It's not going to decrease away. So it's distance, how many spaces away from 0. So we start with an example over here. Obviously, if you have negative 12, so the value of negative 12 is 12. And if you look at the little x here, absolute value of x, there's 3 scenarios. It's x if x is positive, it's 0 if x is 0, and it's negative x if x is negative. Like think of it as a double negative to cancel it out. So it's a little bit more of an algebraic way to look at it. Now, assignment 13, the first page of it, is pretty much going to be some problems that we're going to work on in class together to, that go along with the lesson. I don't talk too much about some of the basic absolute value problems, so that's why if you read down here, it says take a minute to work on numbers 1 to 3 of assignment 13. Just some basic absolute value problems. So if you want to, pause the video and actually work a couple of those out before we move on. All right? All right, so in the homework packet, you took a look at some basic problems, solving absolute values for them. Now we're going to take a look at it from an algebraic standpoint. So we have a title here. It says solving an absolute value equation, and then I would read that absolute value, ax plus b equals c. Now what happens when inside the absolute value, it's just not a single number or single sets of operations? What if I have a variable in there? And there's 3 steps to solving it, and you can write these along as I go. Step 1, in order to solve them. One second here. The whole thing's not supposed to disappear. All right, so here's our steps. Had a little technical difficulty where, I had a button that I was pressing on it to come up with each of 3 of these, and the whole thing disappeared, so I fixed it now. So here's our steps. If you have an absolute value, I say ax plus b equals c. All right. First, we're going to get rid of the absolute value bars. And step 1 says write 2 equations, ax plus b equals c or ax plus b equals negative c. So we're taking away the absolute value bars and we're modifying the change of what the numbers could be by the numbers off to the right. So instead of, changing all the signs inside, we're taking it to the other side of the equation. That's the hardest part. Once you know how to write them, step 2, solve each equation. You have 2 equations for each of these. 3, make sure you check each solution in the original absolute value equation. Okay? Now, to solve our problem here, take a look at example 1. Solve absolute value 2x minus 9 equals 15. So once again, we are not changing any sign or anything inside the absolute value bars. The rule is to change it to the right. It makes it a little bit easier. And on that previous slide, when we talked about the example under the absolute value term, last slide, we talked about if it's absolute value, we want the positive version, the negative version of it. So what I'm actually going to do here to solve them, I'm going to type it out as I go here. Here's my first equation, 2x minus 9 equals 15. And I'm going to put the word or. We're going to go 2x minus 9 equals negative 15. So that's it for solving them. Now I have 2 equations to solve that will give me 2 values that will work if I would plug them back into the absolute value equation. So you can pause the video and solve them. They're pretty straightforward, all right? And then I will show you the work along with it. You move 9 over, the negative 9 as a positive 9 to the other side. and we transpose, then I get 2x equals 24. Then when we divide, you should get 12. Okay, so that's our first answer there. Let's do the next one. 2x equals negative 15 plus 9. I get 2x equals negative 6. When I divide, I will get x equals negative 3. So here's our answer. All right, and I'm going to actually draw around it there. Let's move that. How I would write my answer, I know I have a really big space here for us, but I would write my answer once I solve them as x equals 12 or x equals negative 3. Now what I'd like you to do is to pause the video, take a minute, plug 12 back in to the original. What do I mean by original? I don't mean here, this original equation here. Plug 12 back in, see what you get, make sure it equals 15. And then take negative 3, plug negative 3 in, make sure you get 15. You have to check each solution because sometimes both answers won't work out, and we'll get to that shortly. All right, so pause for a minute, check your work, verify that 12 and negative 3 are both correct. All right, so here's our next example, example 2. Once again, why don't you try solving yourself, pause the video, try to work it out. All right. So remember, I dropped the absolute value bars, rewrite it as is, the original. Then I keep it as 4x plus, oops, 1 second there. Equals negative 28. Once again, you're changing the sign with the single number off to the right. It's easier that way to manipulate the fact that to take care of all the absolute value answers, you change the number on the right. All right, so we'll solve for x equals 28 minus 12, right? For x equals 16. And when I divide, I get x equals 4. All right, let's see our next one. 4x equals negative 28 minus 12. Get negative 40. When I divide both sides by 4, I get x equals negative 10. And those are our answers. Make sure, once again, step 3 says to check your work. I want you to verify that they both check out. Like I said, at this point, you guys are well aware of how to check answers. So I'm going to have you do it yourself and make sure they work. Because you'll see in the last one we do today instances where they might not check out. All right, so the terminology below, we have a term, extreme solution, an apparent solution that must be rejected because it does not satisfy the original equation. So you know how I'm saying step 3 is to check your work. Sometimes both don't work. Sometimes maybe neither will work out. Sometimes both work, sometimes one, sometimes none. All right, we're going to take a look at what that means. Now, why might I have an extreme solution? How does example 3 look different from examples 1 and 2? I now have a variable. I have 6x, not just 6. So chances are if you have a variable inside the absolute value bars and also off to the right without absolute value bars, that might make a difference. I'm going to set it up though exactly the same way. So 4x plus 10 equals 6x. So my first equation is exactly like the original. If I didn't have absolute value bars, we drop them, right? 4x plus 10 equals negative 6x. So even though it's a variable, we want to also change the sign. And if you had more than one piece on the right, you would change everything with its sign. That we'll get to more in class. All right. So let's bring the x's over. 4x transpose the 6x over is a negative 6x. And you know, in the same step, I'm going to move the 10 over to the right as negative 10. So make sure you're okay with my transposing here. Get negative 2x equals negative 10. And then when I divide, I get x equals 5. Okay? Solve the other one. 4x plus 6x equals negative 10. So I'm transposing the positive 10 over as negative. Negative 6x comes over as a positive 6x. All right. Then I get 10x equals negative 10. When you divide, you get x equals negative 1. So here's my answers. All right. Now, I've said before in examples 1 and 2, I still want you to check them. We're going to check them again here, and I'm going to show you the work to plugging them back in. All right. So I'm going to write check. Remember, we plug them into the original. So I'll start with 5. 4, open parenthesis, 5 plus 10 equals 6 times 5. Let's see what we get here. We get 30, absolute value of 30, when we simplify order of operations equals 30. And on the left-hand side, we know the absolute value of 30 is 30. Okay, so this one works out. We're okay with that one. So 5 is a correct answer. And usually what I just like to do is when I solve it and it works, I put a little check mark there. All right, well, let's try the other one. All right, so you have plug negative 1 back into the original. So always the original, not what you solved. And you'll probably start to see what the issue is going to be in this one. Absolute value clears to absolute value of 6. And on the right-hand side, I get negative 6. So absolute value of 6 is 6, but we'll notice we have an issue here because 6 does not actually equal negative 6, right? Doesn't equal it. So why you might have an extraneous solution is when there's variables on the side without the absolute value bars. That there's no absolute value bar on the right to make it always a positive number. So as you can see, the numbers are right, it's just the signs are wrong. So what I'll go back and do is cross out negative 1. My final answer is just 5. Now with extraneous solutions, you could have one solution, you could have two solutions, you could have none solution, or no solution. So you do have to plug them back in to check, okay? All right, that's it for part 1, homework problem of the day. To solve the equation, check for extraneous solutions. All right, I have a mix of them with variables and without. All right, and it's actually a pretty short amount of homework today. So make sure you go through everything and be ready for class. All right, guys, good job today.